Just a moment.
Okay.
Okay.
Part 2. When we looking for particular consensus algorithm for our blockchain, we need to see which is best. And here was this science a little bit flow away. So this proof of the stake algorithms are probably the best because they rely on some agreement, but not on the burning or some work and so on. So it's economically possible to use them. Well, we had some experiments with Hyperledger stack, as this Hyperledger is public available, and then you can make new blockchains on it. The success story, for example, is in Lithuanian bank. Lithuanian bank, on the base of Hyperledger, provides some platform called LB chain for the fintech startups who would like to play with that blockchain. So we also decided to choose Hyperledger and may have made some experiments. Now here probably I will not go to very details. In one conference I presented detailed inspection which this consensus algorithm from the previous could be better to component-based blockchain of components, and I stand on the shoulders of Sarah Buraga. She made a taxonomy of blockchain consensus protocols. So we inspect this algorithm protocols by origin, design, performance, issues, and the security. And here in the slides, which I believe it's possible to see, if you're interested more, the paper is available also. After this inspection, we conclude that some particular algorithms, consensus algorithms, are the best solution. Solution here. As my goal is to present my directions, I am not going to more details very much, but they are available here. So another try to use something for software engineering is to use optimization methods. And here I will present two my approaches. Well, one I started actually in first MIPRO conference where I participated in maybe 2008. We present something with my colleague related to that. Here we have also the problem of composition. So we define this problem that we have many different components with the same interfaces, and we would like to get optimal collection of that components for the system. As interfaces are the same, or for example, one component can only one interface, so another have two interfaces, and so on. We can choose also by the additional properties, additional credentials, such as security level, size, performance characteristics, and so on. But no, still, this is a problem for optimization. So we made, with my colleague Professor Sakalauskas, made an approach to use simulated annealing method, simulating annealing method, here for finding an optimal set of components. As some components are similar, we also improved this simulated annealing method with a variable neighborhood search element, and here we can see that some some results are better than classic algorithms such as Grady and so on. And our goal function here is to have a set of components which with best sum of marks on the performance, security, and other credentials. As I mentioned before, it was quite old work, but very recently, this year, we got a new taxonomy of optimization methods, and here is a Stork search. They made a new step and provide taxonomy for state-of-art optimization algorithms, because during past 20 years, some surrogate-based algorithms comes and so on. We have many hybrid approaches, so they still needed to be classified. So if we have new, and also what I would say that it's pity that I cannot come back. But my approach wasn't only one. There are plenty of papers in which some optimization methods are used for software improvement, for service-based programs or component-based programs. So here was a point to see how deep this area already investigated, and especially having this new taxonomy with two new class, we made some research on how deep this is investigated, and we take we just as a how to say input, take it papers from IEEE Explore, ICM Digital Library, Science Direct, and so on. And according to some keywords, we see how many each group of optimization methods from this taxonomy is covered. So here we saw that probably such classical algorithms like a height, clipping, or trajectory are already used, and they not need some improvement. But for example, hybrid and some other algorithms still are not used or not used in good extent for component-based software development. So mainly we are interested with surrogate optimization. Actually, normal cases in other areas are used when we would like to quickly test we are going to go good direction or not, in order to escape local maximums or local minimums. So having distributed how to say market of components and services distributed, I think that surrogate class could be very interesting to see. And the third try to do something good for software engineering is artificial intelligence elements, and here is not yet published material. I with my colleagues present to some upload to some conference. We will fighting for waiting for results. Idea is that now we either use automated software engineering, or we are use very human oriented how to say activities. One of this is crowdsourcing. Well, crowdsourcing have many phases. For example, crowdfunding is quite popular in Lithuania. On the basis of crowdfunding, we collect few millions of euros, both Bayraktar drone for Ukraine. So we are very proud of, about this, but it's also it's possible to have some crowd collaboration, perform some crowdcasting, and so on and so on. And there are some platforms which allow to perform any tasks, and they are especially popular for students. If you have free time, you can register as a worker, perform some few tasks, and then get some money. But crowdsource for software engineering also is used, and I know at least few workshops which already have been organized about crowdsourced oriented software engineering. And here we have even some academic platforms which are how to say dedicated especially for some life cycle phases. For example, Crowd Require is a platform for working with the requirements. CodeOcean, which I mentioned before, is for distributed development. Especially popular is a testing part, because, well, maybe half of software engineering related crowds are related with test, and we have a lot of commercial testing platforms and so on. But also we have and this one. So this one side that we have used crowdsource for the software engineering. Another thing what is well gaining popularity is usually using artificial intelligence elements such as machine learning to software engineering. And here are two recent books. I think this one is maybe made in 2021 about the subject. This data democracy had only one chapter about using artificial intelligence in software engineering, but still there are achievements. So we with colleagues have the idea that if we have this both sites, it will be interesting to have a mixed platform. For example, well, in these papers are stated how to say cases when this human factor in crowds have weakness. So our idea is to make some bot, no, let's say, who can be in the crowd and work together as a human. So these bots actually have a bad name in other things. You know now we have a big problem with propaganda in Facebook, Facebook bots, and so on and so on. So to put a bot inside crowd, well, it's a danger. But well, it will be interesting to see what game we should have here. So in this paper we discuss about possible collaboration between two sides in crowd source. For example, it can be parallel task, it can be sequential task, it can be repetitive collaboration, and so on. And we go through each stage of life cycle. For example, what is good for requirements, what is good for design, and how exactly this collaboration between AE element and the real crowd could be organized. For example, in development area, we already have this no, as a fact. There is a GitHub pilot. I use a GitHub pilot. It's a very nice AI, artificial intelligence based software. Now I think it's available worldwide. Was before half of year you must be registered, and then after that you like pre-order, you get possibilities. So I try it. You just install this GitHub Copilot and started to work as a normal program. And this GitHub Copilot started to offer you something. Let's finish this snippet of code like this, but not like IntelliSense in programming language, which provide only one function, but some blocks of the code. It recognizes some patterns what you do. So initial data source for that GitHub pilot is repository of GitHub. This now raises some ethical questions, but wait a minute, why did this I use it? Maybe some code, pretty code is used in another project, and so on and so on. Well, it's almost famous, almost. But what is good side with that GitHub pilot? It learns from you. If you said no, I not agree on that, I will do in other way. After some time, it offers your style code, your style code. So the more you provide information for that GitHub pilot, the more effective it is. So and this GitHub pilot is maybe famous, but also in the paper I found yet another similar product who do the same. About the maintenance, one of the questions of the maintenance is to get something what user want. So now in many websites there is some chatbots which started to chat with you. They are completely stupid. I hate this chatbots. Because for real, what you can do with real people with 2 sentences, then you make conversation in maybe 8 or 10 sentences, and still you have provided some phone number, and that's it. But the fact is that products are already there, and for example. One of the maintenance task of the maintenance is localization. If we move to another market of another country, maybe we need yet another language. Implement user interface, another language add. And usually in the crowds, people just translating, giving a list of this resources, the different words, and then we have different interface. So that's why, for example, Linux interface not English speaker, I found better than Windows interface when they're not English speaker, because people doing this. But here, for example, it is possible to use, for example, DeepL. DeepL is maybe I use it. There is a site even based on that DeepL, and if you would like to translate something, you can use not Google Translate, but this DeepL, and the sentences are more nice and it's also sometimes you don't have a feeling that they are translated not by humans. So it's pretty possible because we have particular products which are here. I have no idea currently how deeply we will go there and what exactly we will have here, but no, we will see. Maybe after this conference we get more input. And have a 5 minutes. Yes.
Yes.
Okay. So, and the third interesting scientific direction of among my is scientific software. We have a problem that scientific software. Who made scientific software? We either use some engineers who have not big knowledges about the field. They can do programming, but they know less about the chemistry, physics, or so. Or the software is made by scientists or research engineers who are related with a particular subject. For example, they are physicians, mathematicians, or so, but they worry less about requirement specification, about the testing process. It's working nice. Why we need to do something like that? And after some years, the maintenance of that product become as a nightmare because people who've written that software not working anymore, and so on and so on. I had one experience that colleagues of mine worked on the research on environment. They collect samples of polenta in the air. No, when the flowers are blooming, so some polenta particles go, and some people who are allergic have a problem. So group of scientists collect this information, and on the basis of this information, even provide some forecasts, like we have a forecast for the weather. They provide forecast of this polenta moving. So now it's completely mature product, but about millennium 2000 years of 2000, I have been asked, can we specific software which was made by Finnish Institute of Meteorology, can we provide, no, can we remake this product in order it work with the grid and HPC computing, in order to get this forecast more speed. Well, and there was a challenge. Personally, I went to Finland to that particular person to get the details, how this software is made, what's the inputs, what's the outputs, and so on. No reliable documentation, only one documentation how to run this software, but no elements of software engineering. So I think it's not good. So my idea is somehow to put more software engineering to scientific software. But well, the most maybe most problematic thing that we need to define formally what is scientific software formally. Okay. Here are some books. What is interesting is a book of colleague Codona, which surveys software engineering on specific country, namely Japan and so on. But usually now the zoo of scientific software is quite big. We have some software for the life sciences, physics and mathematics. We have such like EVUs, SPSS for the business. We have for data mining this Veka, Datadog, and so on. There are plenty of commercial products, and also we have homemade software which also have the problems. And to put all this, how to say, software on the one plate and call it scientific software, well, it is possible, but different kind have different problems, because these commercial products, at least they provide support. We don't have any issues with the support. Yes, but if we go to some open source, for example, this Octava or this Maxima, they are open source community, and here rules are different. Support is like, well, we know this is like no issue. We will fix maybe 10 years ago, so 10 years future. So something are bad here. Okay. So this is the end of my presentation. Hope you find interesting moments here, and I think that I will find some collaborators to my research areas.
Thank you very much.